North Carolina Institute for Transportation Research and Education presents Pavement Structure Repair Techniques, Crack Sealing.
So do you think we should seal these cracks?
I think so. The cracks are about a 1/4 inch wide. If we seal them now, we can keep the water out of the base and prevent further deterioration.
Crack sealing in asphalt pavements has long been a cost-effective pavement maintenance activity. However, unless it is performed properly, the benefits are minimal to the pavement or the traveling public. The objective of this presentation is to illustrate a clear, simple, and effective crack sealing procedure for asphalt pavements. This procedure is designed for small road maintenance crews. The purpose of crack sealing is to prevent surface water infiltration and thus slow the rate of pavement deterioration. A 4-step procedure will be presented for sealing cracks. Following these steps will result in effective crack sealing and an extended pavement life. The 4 steps are: 1. Crack analysis and identification. 2. Crack cleaning and preparation. 3. Application of sealant. 4. Squeegee cracks. Before these activities can begin, however, proper traffic control measures must be in place. The supervisor should consult the MUTCD or other appropriate work zone traffic control standards to determine the traffic control needs. For more information, refer to the supplemental videotape, Basic Traffic Control for Pavement Structure Repair Techniques. With proper traffic control in place, the crack sealing operation can begin. The equipment needed for crack sealing includes an air compressor, preferably with a hot air lance, an asphalt distributor with a wand applicator, and a squeegee. The first step in the crack sealing process is performing crack analysis and identification. This is done to identify those pavements which exhibit the type and severity of cracking that warrants crack sealing. Block cracking, also called shrinkage cracking, is a distress which often warrants crack sealing. Daily temperature changes cause expansion and contraction in the pavement. As the pavement ages and hardens, it is less able to withstand this stress. It pulls apart, creating block cracks. Block cracking most commonly occurs on plant mix pavements. Block cracking begins as transverse cracks. These transverse cracks eventually become connected with longitudinal cracks, forming blocks, hence the name block cracking. Block cracks are not a load-associated pavement distress and do not represent a structural failure of the pavement. However, if these cracks are not sealed, water can freely enter the base and subgrade. This will weaken the pavement and lead to structural problems. A widening joint also needs to be sealed when open. Usually, a crack will form along the joint between the original pavement and the widening strip. Reflective cracking also requires crack sealing. This cracking occurs where Portland cement concrete pavement has been overlaid with asphalt. Usually, the joints and cracks in the concrete pavement will reflect to the surface. These cracks should be sealed to prevent water and incompressible material from entering them. Crack sealing is an effective maintenance activity for all of these types of cracks. Cracks must be wide enough for the sealant to enter the crack. Cracks should be approximately 1/4 inch wide. A rule of thumb: if a pencil will stand up in the crack, it needs to be sealed. It is not cost-effective to seal all cracks. For very narrow cracks, other sealing techniques, such as slurry seal, may be used. Some pavement sections may have extensive block cracking with small blocks of 2 to 10 square feet formed. Alternate maintenance repair procedures, such as chip seals or overlays, need to be considered. For these conditions, crack sealing would be too time-consuming and expensive to be cost-effective. The preferred time of year for crack sealing is the winter, when cracks are their widest. However, rubberized asphalt sealants make year-round crack sealing possible. The second step is crack cleaning and preparation. A clean and dry crack is essential if an effective bond is to be formed between the crack sealant and the pavement. Clean the cracks with compressed air, or preferably a hot air lance. Compressed air effectively removes dust, sand, and other incompressible matter from the crack, providing a clean face for bonding. The hot compressed air lance combines high pressure with a flame to heat the air. This dries and cleans the crack at the same time. In addition, the asphalt pavement is heated somewhat, and the asphalt binder is softened to aid the bonding of the sealant. The hot air lance also burns away organic matter in the crack that would interfere with the sealant bond. The operator is careful to keep moving so the lance does not burn and damage the asphalt pavement. The hot air lance ensures a dry surface for the sealant bond. Often the surface of a pavement appears dry, but moisture remains in the cracks below the surface. The hot air lance dries this latent moisture. Clean the cracks of loose debris to a depth approximately equal to or slightly greater than the crack width. With the cracks now clean and dry, the third step is the application of the crack sealant. Selection of an appropriate crack sealant is essential if the crack sealing operation is to be effective. What are the requirements for a good crack sealant? A high-quality sealant should exhibit the following: good bonding or adhesion characteristics, flexibility and extensibility, ease of application, resistance to softening, resistance to tracking, adequate pot life at application temperatures, resistance to weathering, compatibility with asphalt pavement, rapid curing. In many areas, cutback asphalt, emulsified asphalt, and lean sand asphalt have been used for crack sealing. These materials have yielded mixed results, but generally provided a short service life. In response to a need for a better asphalt crack sealant, numerous proprietary sealing materials have been developed. Most of these products can be classified as some form of rubberized asphalt. These rubberized asphalt materials are relatively expensive, but are more effective, with an expected service life of 3 to 5 years. Rubberized asphalt sealant is recommended for effective crack sealing. Rubberized asphalt sealant requires special equipment for handling and application. Take care to maintain proper temperature of the material. Follow the manufacturer's recommendations for handling and placing sealants for best results. Step 3 is the application of the crack sealant. Place the sealant using an applicator wand attached to a sealant machine. The use of a wand ensures that proper application temperature is maintained and eliminates additional handling of the material. Pour pots have traditionally been used for crack sealing. Though not preferable, they can be used with rubberized asphalt. The sealant may cool quickly in the pot and need to be reheated. This is more critical during cold weather application. Rubberized asphalt sealant is placed at high temperatures, so safety must be emphasized. Workmen must wear gloves for protection. Fill the crack to a level equal to the surface of the pavement. Do not overfill the crack, because this creates a buildup of material on the surface. It may be torn away during snow plowing and may cause a poor ride quality. For cracks wider than 1 inch in width, conventional crack sealing procedures will probably not suffice. It is suggested that the crack be cleaned and a lean sand asphalt type mix be inserted and tamped. The fourth step is to squeegee the just sealed cracks. The squeegee operation levels and smooths out any excess sealant. It results in a thin film of sealant across the pavement that aids in sealing the crack. This operation follows immediately behind the applicator, usually within 5 feet. This is necessary because the sealant material cools quickly and is difficult to squeegee once it cools. Rubberized asphalt sealants do not require any blotting material after application. Once the sealant has cooled, the road is ready to be opened to traffic. The time required is approximately 15 minutes. Now, let us briefly review the 4 steps of crack sealing. The first step is to perform a crack analysis and identification. This is a review of pavement sections to determine which exhibit the conditions warranting crack sealing. Block or shrinkage cracks, widening joints, and reflective cracks should be sealed. Crack widths of approximately 1/4 inch wide require crack sealing. A rule of thumb: if a pencil will stand up in a crack, it is wide enough to be sealed. The second step is crack cleaning and preparation. Cracks must be clean and dry for sealants to bond to the pavement. The best method of crack cleaning and preparation is the use of a hot air lance. The hot air lance removes dust, sand, and other debris from the crack and also dries any latent moisture which may remain in the crack. It also heats the asphalt surface and softens the asphalt binder, aiding in bonding of the sealant. Any organic material is also burned away. Clean cracks of all loose debris to a depth equal to or slightly greater than the crack width. The third step is sealant application. Proper application of the sealant is critical if the sealant is to perform effectively. A rubberized asphalt sealant is recommended. It exhibits the desired requirements for a good crack sealant. Maintenance of proper material temperature is important. Follow all manufacturer's specifications for handling and placement for best performance. Apply the sealant with an applicator wand attached directly to a sealant machine. Fill cracks to a level equal to the surface of the pavement. Overfilling of cracks should be avoided because this buildup is susceptible to removal by snowplow operations and results in a poor ride quality. Squeegeeing of the cracks is the fourth step in this procedure. Use a hand-held squeegee to smooth out any excess sealant after application by the sealant wand. The squeegee follows immediately behind the application wand because the rubberized asphalt cools quickly. Once the sealant has cooled, the roadway is open to traffic. No blotting is required with rubberized asphalt. Using these operating procedures will result in effective crack sealing and will protect the pavement and retard future deterioration.